So, data science. It sounds massive, right? Kind of intimidating from the outside. But here's the thing. Just like any master craftsperson, a data scientist really just has a specific set of tools they use to get the job done. Today, we're going to pop open that toolkit and give you a real quick tour of the absolute essentials. All right, let's get into it. Okay, so this is the map we'll be using for our tour today. It does a pretty amazing job of breaking down the entire landscape of data science into its core pieces. Just think of this as our guide while we explore each of these areas one by one. So here's our game plan. We're going to start with the languages data scientists actually speak, then look at the math that, forms the bedrock of their logic. After that, we'll walk through the actual process of turning raw numbers into powerful stories, touch on the magic of predicting the future with machine learning, and finally, we'll stop by the digital workshop where it all comes together. First stop, the core languages. You can't build anything if you can't communicate your instructions. And in the world of data science, that means speaking the language of the machine. The two heavyweights you're going to hear about constantly are Python and R. Python is kind of like a Swiss Army knife. It's incredibly versatile, and you can use it for pretty much everything. R, on the other hand, is more of a specialist's tool. It was born out of statistics, so it's exceptionally powerful for deep analysis and creating really complex visuals. And our map also points out Java, which is another player, often used for those bigger enterprise-level projects. But let's be real, code is just a tool. The real power, the logic that makes everything tick, well, that comes from mathematics. This is the foundation that everything else is built on. You've got three main pillars here. First, statistics. That's how we figure out if a new drug is actually working or if it's just a placebo effect. Then there's linear algebra. Sounds scary, I know, but it's really just the math that powers the spreadsheets and data tables we all use every day. And finally, differential calculus. That's the key that allows a self-driving car's computer to perfectly tweak its speed based on the car right in front of it. Okay, so you've got your programming language and you understand the math. Now what? Well, now you actually do the work. This is the journey from a messy, jumbled pile of raw data to a clean, compelling insight. You can really think of this whole process like a pipeline. First, you've got to get the data, sometimes using tools for web scraping to pull it right off the internet. Next comes the really crucial stage, data analysis, where you clean it all up and just explore. And finally, you tell the story you've uncovered through data visualization. Now, a huge part of that analysis step is something called EDA, or exploratory data analysis. And I absolutely love this definition. It's the process of interviewing your data. It's like you're a detective, asking questions, looking for clues, and just getting a feel for the story before you present your case. But what good is a brilliant discovery if you can't communicate it, right? An insight is useless if no one understands it. So tools like Tableau, Power BI, and Python libraries like Matplotlib are like the paintbrushes data scientists use to turn their findings into charts and graphs that anyone can look at and just get. All right, let's get to the part of the toolkit that honestly feels a little bit like magic, predicting the future with machine learning. This is where a data scientist goes from just analyzing the past to making really smart, educated guesses about what's coming next. See, machine learning isn't just one single thing. It's more like a whole menu of different techniques or flavors, if you like. You've got methods for classifying things, like figuring out if an email is spam or not. You've got regression to predict a number like a house price. And you've got clustering to find natural groups in your data, just to name a few. Yeah, I know, that all sounds super technical, so let's just cut through the jargon for a second. What is this stuff actually doing? Well, think about it like this. Instead of a programmer having to write a million if this, then that rules by hand, you just give the computer a ton of examples and a goal. And then it learns the patterns from the data all by itself. You're teaching the computer how to learn instead of just telling it to follow a rigid list of instructions. So finally, where does all this work actually happen? Every great artisan needs a workshop, right? For a data scientist, that workshop is completely digital. On one side, you have your IDE, or Integrated Development Environment. The easiest way to think about this is as your digital workbench. Tools like Jupyter Notebooks, RStudio, or PyCharm are where you write your code and build your models. Then, once your project is ready to go, you use deployment platforms, usually cloud services like AWS or Azure, to share it with the world so people can actually use it. And that really brings us to the whole point of this entire toolkit. It's never just about having the data. It's about the journey. It's about turning that data into a genuine insight, and then turning that insight into a real-world action that makes a difference. So there it is, a whirlwind tour of the Data Scientist Toolkit. We've looked at the languages, the math, the processes, and the platforms. It really just leaves you with one final thought. Now that you've seen all these tools, what problem would you be most excited to solve first?